Welcome to Mythos AI, your source for Cliff's Notes on complex subjects. Join Anna and Phil for yet another engaging conversation.
Welcome to our deep dive into the steam engine. You might be surprised to learn just how much this one invention changed the course of history.
Absolutely.
We're going to explore its impact on everything from industry and transportation to the very fabric of society and how scientific principles and engineering breakthroughs fueled its development.
That's right. This isn't just about gears and pistons.
Right.
We'll uncover the steam engine's wide-reaching social, economic, and even environmental impact. Raising some thought-provoking questions along the way.
Let's start with the concept of steam power.
Okay.
Which actually dates back to ancient Greece.
Yes. Hero of Alexandria's aeolipile is a fascinating example of early scientific curiosity.
Right.
This device used steam to spin a sphere.
Oh, wow.
Demonstrating the potential of steam power centuries before its practical application.
Why wasn't this technology harnessed earlier?
Well, while it was an intriguing concept, the need for a practical application hadn't arisen yet.
Right. It wasn't until the 17th century that a real demand for steam power emerged, driven by the mining industry.
Whoa.
As mines became deeper,
Right.
they needed better ways to pump out the water.
Interesting.
This need drove innovation and pushed inventors to find practical applications for steam power.
So it was necessity rather than pure invention that led to the first practical steam engine.
Precisely. And that brings us to Thomas Newcomen and his atmospheric engine, which he invented in 1712.
This engine was a major breakthrough, wasn't it?
It was the atmospheric engine, while inefficient by today's standards, was a remarkable feat of engineering for its time. Imagine a large cylinder with a piston inside. Steam is introduced into the cylinder, pushing the piston up. Then cold water is sprayed into the cylinder, condensing the steam and creating a vacuum.
And this vacuum is what drives the engine.
Exactly. The vacuum allows atmospheric pressure
to push the piston down with considerable force. And this force is used to operate a pump to remove water from mines.
So the engine doesn't generate power from the steam itself, but rather from the vacuum created by condensing the steam.
You got it. The engine is powered by the difference between atmospheric pressure and the low pressure inside the cylinder.
Interesting.
After the steam condenses. This design, although inefficient, proved that steam could be harnessed to perform work on a large scale.
What made it inefficient?
The constant heating and cooling of the cylinder wasted a lot of energy. The cylinder had to be cooled down to condense the steam for the vacuum, then heated up again when steam was introduced for the next cycle. This stop-and-start process consumed a lot of fuel and limited the engine's speed and power.
This is where James Watt enters the picture and revolutionizes the steam engine with his separate condenser.
Exactly. In the 1760s and 1770s, James Watt, a Scottish engineer, made several groundbreaking improvements to the steam engine. Perhaps his most significant innovation was the separate condenser.
How did the separate condenser work?
Instead of cooling the entire cylinder to condense the steam, Watt added a separate chamber where the steam was condensed.
Interesting.
This meant the cylinder could remain hot, dramatically increasing efficiency.
That sounds like a simple yet brilliant solution.
It was. This innovation, however, was directly linked to another breakthrough in scientific understanding. The concept of latent heat, developed by Joseph Black, played a crucial role. Latent heat is the energy absorbed or released during a phase change, like when water turns into steam or vice versa.
So how does latent heat relate to Watt's separate condenser?
Watt's engine, by keeping the cylinder hot and condensing the steam separately, harnessed this latent heat much more effectively. This drastically reduced the energy lost in each cycle, allowing the engine to produce more power while using less fuel.
So Watt's engine wasn't just a mechanical improvement.
It
was a leap forward in understanding the science behind steam power.
Absolutely. In fact, this understanding laid the groundwork for the development of thermodynamics, a branch of physics that studies how energy is transferred and transformed, particularly focusing on the relationship between heat and mechanical work.
Was Watt's engine immediately successful?
It faced some initial resistance, but it soon became clear that it was a game changer. It's important to note that this success wasn't solely due to Watt's ingenuity. His partnership with Matthew Boulton proved crucial.
Boulton, a successful businessman,
Yes.
provided the capital and business acumen needed for the wider adoption of Watt's invention.
Yes. And Boulton's marketing skills.
Okay.
And understanding of market need.
Helped make the steam engine a commercial success.
Interesting.
The collaboration between these two men demonstrates the crucial role of business savvy and marketing in the success of technological innovations.
Watt's engine was a massive leap forward.
Yeah.
But there were more advancements to come.
Absolutely.
Who were the next innovators to refine the steam engine?
The story of the steam engine takes another exciting turn in the early 19th century with the work of Richard Trevithick and George Stephenson.
This is where the steam engine goes from stationary to mobile, right?
That's right.
Okay.
Trevithick pioneered the use of high-pressure steam, which allowed for smaller, more powerful engines suitable for locomotion.
Yeah.
Stephenson then refined these designs, creating the iconic steam locomotive rocket, which set the stage for the railway revolution.
Before we get into that revolution, can you explain what high-pressure steam is and why it was so significant?
Certainly before Trevithick, most steam engines operated at low pressures, just slightly above atmospheric pressure. This limited their power and efficiency.
Got it.
Trevithick experimented with boilers that could withstand much higher pressures.
Interesting.
Allowing him to generate more power from a smaller engine.
Why was a smaller engine so important?
Think about trying to put a large, low-pressure steam engine on a carriage or a train. It would be too heavy and cumbersome to be practical.
I see.
High-pressure steam allowed for compact and powerful engines, paving the way for steam-powered transportation.
So the move to high-pressure steam was driven by the need for mobility.
Exactly. And this shift required not just ingenuity, but also advances in materials, science, and engineering. Boilers had to be made stronger to withstand the increased pressure, and new techniques were developed for machining precise components that could handle the stresses and temperatures involved. It sounds like the steam engine's development was a constant interplay between pushing the boundaries of what was possible and overcoming the technical challenges that arose.
You're absolutely right. And this interplay drove a wave of innovation that extended far beyond the steam engine itself.
Interesting.
It spurred advancements in metallurgy, manufacturing processes, and even our understanding of basic scientific principles.
Let's delve further into those advancements.
Sure.
We talked about thermodynamics earlier. How did the steam engine contribute to this field of science?
The steam engine, as a practical application of heat and energy conversion, forced scientists and engineers to grapple with questions about efficiency and the limits of converting heat into mechanical work.
So they were trying to figure out how much work they could get out of a given amount of heat.
Precisely. And this led to a deeper understanding of the relationship between heat, work, and energy. For example, the concept of entropy.
Interesting.
A measure of disorder or randomness in a system emerged from studying the steam engine and its inherent limitations.
And this scientific exploration wasn't just theoretical, was it?
No, not at all.
It had real-world implications for the development of more efficient engines.
Absolutely. Sadi Carnot, a French engineer and physicist, published a groundbreaking work in 1824 titled Reflections on the Motive Power of Fire.
Interesting.
In this work, he laid the foundation for the second law of thermodynamics, a fundamental principle that governs energy flow and efficiency.
So even though Carnot was studying steam engines, his work had implications for all types of heat engines, even beyond that, for our understanding of the universe itself.
Exactly. His insights help define the theoretical limits of how efficiently heat can be converted into work, concepts that are still fundamental to our understanding of energy today.
Carnot's work was a major theoretical advance.
It was.
But what about the practical challenges of building better steam engines?
Well,
what were some of the key hurdles engineers faced?
Early steam engines faced numerous challenges. Excessive fuel consumption was a major problem, making them expensive to operate. They also suffered from pressure loss due to leaks and inefficiencies in the design of boilers and cylinders.
I see.
And perhaps most importantly, the materials available at the time limited the pressures and temperatures they could withstand.
So how did they overcome these challenges?
They made remarkable progress in boiler design,
Okay.
improving their ability to withstand higher pressures safely.
Right.
They developed new techniques for sealing joints and valves to minimize pressure loss. Lubrication technologies advanced, reducing friction and wear on moving parts. And perhaps most importantly, the development of precision machining played a crucial role.
Why was precision machining so important?
Because even slight imperfections in the fit of components could lead to significant losses in efficiency.
Right.
Imagine trying to build a powerful engine with parts that fit together poorly. Steam would leak. Energy would be wasted.
I see.
It'd be like trying to run a marathon with shoes full of holes.
Right.
Precision machining allowed engineers to build engines that were tight, efficient, and reliable.
It's a reminder that even in the age of steam, the quest for precision and quality was paramount.
Absolutely. These engineering advancements, combined with a deeper understanding of thermodynamics, allowed the steam engine to truly fulfill its potential as a driver of industrial and societal change.
Right.
And that brings us to the Industrial Revolution.
Let's discuss how the steam engine transformed industries and economies. How did it all begin?
The steam engine was a catalyst for unprecedented industrial productivity. Before its arrival, most manufacturing relied on human or animal power, water wheels or windmills. These sources of energy were limited and unreliable.
The steam engine offered a more powerful, reliable, and scalable source of energy, didn't it?
You're right. It allowed factories to be built anywhere, not just near rivers or windy areas. It powered the mechanization of various industries, transforming manual labor into automated production lines.
Which industries were most affected?
The textile industry was perhaps the most prominent example. Before the steam engine, textile production was a slow, labor-intensive process, often done in homes or small workshops.
So how did the steam engine change that?
Steam-powered spinning and weaving machines revolutionized textile production, leading to a dramatic increase in output and affordability. The speed and efficiency of these machines made it possible to produce fabric on a scale never before imagined.
This must have had a huge impact on the textile industry.
It did. Factories replaced small workshops, and mass production became the norm. This shift not only lowered the cost of clothing, but also created new job opportunities in factories, even as it displaced some traditional textile workers.
What about other industries?
The coal and metal industries were also significantly impacted. Steam-powered pumps enabled deeper mining of coal, which in turn fueled the steam engines themselves, creating a positive feedback loop.
Interesting.
And in metallurgy, steam-powered blast furnaces increased the output and quality of iron, essential for building machinery, tools, and infrastructure.
So the steam engine not only powered individual machines, but also entire industries.
It did.
Laying the groundwork for the modern industrial economy.
Exactly. It was a fundamental shift in the way goods were produced and consumed, leading to a cascade of economic and social changes. But those changes weren't limited to factories and production, were they?
You're referring to the impact on transportation, right?
Precisely. The steam engine's impact on transportation was equally profound. It fueled the rise of railways and steamships, which revolutionized logistics and trade. Suddenly, goods and people could move across continents in a fraction of the time it previously took. This led to a surge in global commerce and connected distant regions in ways never before imagined.
The world was truly shrinking.
It was.
Thanks to the steam engine. What was it like before the invention of the steam locomotive?
Imagine a world where the fastest mode of land transportation was a horse-drawn carriage. Journeys that take hours by train today could take days or even weeks. The movement of goods was slow, expensive, and often limited by geography.
So the steam locomotive broke down those barriers.
It did. It allowed for the transportation of large quantities of goods over long distances, quickly and efficiently. This had a profound impact on trade, making it possible to move raw materials to factories and finished products to consumers far more easily.
And this increased trade led to economic growth, didn't it?
Absolutely. The steam engine powered a new era of economic expansion.
Right.
It created new industries, new jobs, and new opportunities for trade and investment.
But this expansion also had a profound impact on the social fabric of society.
Yes. The steam engine wasn't just a technological marvel.
Right.
It was a driver of profound social and cultural shifts.
Yeah.
Its impact on urban life and social structures was particularly significant.
Let's discuss that impact in more detail.
Certainly. But that will have to wait until part 2 of this episode.
Right.
There's much more to explore about the steam engine's legacy, from its role in shaping cities and social classes to its complex relationship with colonialism and the environment.
All right, we'll look forward to that discussion in part 2.
Okay.
Thanks for all this great information so far about the steam engine and its impact on the world.
You bet.
See you in part 2.
Sounds good.
We left off discussing the social and cultural shifts brought about by the steam engine.
Right.
Let's delve deeper into that.
The steam engine was at the heart of rapid urban growth.
Yeah.
Cities expanded rapidly around steam-powered factories, attracting workers from rural areas and leading to a surge in urban populations.
Okay.
This shift from rural agricultural life to urban industrial life was one of the most significant social transformations in human history.
What were some of the driving forces behind this urban migration?
Economic opportunity was the primary pull factor.
Oh.
Factories offered wages and jobs that were simply not available in rural areas.
I see.
As word spread of these opportunities, people flocked to cities in search of a better life. However, this rapid urbanization also created significant challenges.
What were some of those challenges?
Cities struggled to accommodate the influx of people, housing shortages, inadequate sanitation, and social tensions arose as urban centers grappled with rapid population growth.
Interesting.
Living conditions for many working-class families were often cramped and unhealthy, with overcrowded tenements, lacking proper ventilation and sanitation.
These conditions must have been a breeding ground for disease?
They were outbreaks of diseases like cholera and typhoid were common in industrial cities. The lack of clean water, proper sewage systems, and basic hygiene contributed to the spread of these deadly diseases.
So the steam engine, while driving economic progress, also contributed to public health crises in cities.
Yes, it exposed the dark side of rapid industrialization and urbanization.
Okay.
The challenges of urban life became a focal point for social reformers and activists who sought to improve living and working conditions for the urban poor.
So this period also saw the rise of social movements aimed at addressing these issues.
Absolutely. The stark contrast between the wealth of factory owners and the poverty of many workers fueled social unrest. Labor movements emerged, demanding better wages, safer working conditions, and limits on working hours.
How did these labor movements utilize the steam engine's technology?
The steam-powered printing press was instrumental in disseminating the ideas and demands of these movements. It allowed for the mass production of pamphlets, newspapers, and other forms of printed material that could be widely distributed, helping to organize and mobilize workers.
So the same technology that powered factories also empowered those seeking to improve the lives of those working in them.
That's an interesting way to put it.
Yeah.
And this struggle for workers' rights was a defining feature of the industrial age, shaping labor laws, social welfare programs, and the relationship between capital and labor for generations to come.
Beyond its impact on labor and urban life, the steam engine also had a profound influence on the cultural landscape.
Indeed. The steam engine became a symbol of modernity, representing progress and humanity's mastery over nature. This symbolism permeated art, literature, and public consciousness.
Can you give us some examples of how this symbolism manifested itself?
Certainly, authors like Charles Dickens and Elizabeth Gaskell captured both the marvels and miseries of industrial society in their works. They vividly portrayed the harsh realities of factory life, the struggles of the working class, and the social consequences of rapid technological change.
So these authors used the steam engine as a backdrop. to explore the complexities of the industrial age.
They did. Their work served as social commentaries,
Right.
exposing the inequalities and injustices that often accompanied industrial progress.
Okay.
They highlighted the human cost of technological advancement and questioned the unbridled pursuit of progress without regard for its social consequences.
Beyond literature, how else did the steam engine influence cultural perceptions?
The steam engine's visual impact was also significant. The sight of massive steam-powered machines, towering factories with smoking chimneys and bustling railway stations became synonymous with industrial might and progress.
It must have felt like a new era.
It did.
A departure from the past.
The steam engine represented a break from traditional sources of power, symbolizing humanity's ability to harness the forces of nature and bend them to its will. This sense of power and progress influenced art, architecture, and even fashion.
It's interesting how a technological innovation could have such a wide-reaching impact on the arts and culture.
The steam engine's influence was so pervasive because it represented more than just a machine. It embodied the spirit of the age, a belief in the transformative power of technology and human ingenuity.
Speaking of transformation, the steam engine's influence wasn't confined to Europe and North America. How did this technology spread globally, and what was its impact on other parts of the world?
The steam engine's impact was indeed global. Its adoption, however, varied across different regions and played a complex and often controversial role in shaping global power dynamics.
Let's start with the spread of steam technology.
Sure.
How did it reach other parts of the world?
It spread primarily through trade and colonialism. European powers, eager to exploit the economic potential of steam technology, introduced it to their colonies.
Often as a means to extract resources and strengthen their control over these territories.
Can you elaborate on that?
Sure.
How did the steam engine facilitate colonial exploitation?
For instance, in India, the British East India Company, a powerful trading company with its own army, spearheaded the construction of extensive railway networks powered by steam.
What was the purpose of these railways?
While they facilitated trade and transportation within India, they were primarily designed to serve British interests.
How so?
The railways enabled the efficient transport of raw materials, like cotton, tea, and opium, from the interior of India to ports for shipment to Britain. They also facilitated the movement of British troops and administrators.
Interesting.
Strengthening their control over the vast subcontinent.
So the railways, while a technological marvel, also served as a tool of colonial control.
They did. The construction and operation of these railways often came at the expense of local populations who were displaced from their lands and forced into labor on these projects. This contributed to resentment against British rule and fueled nationalist movements in India.
Beyond India, where else did the steam engine have a significant impact in the context of colonialism?
In Africa, the steam engine played a crucial role in opening up the interior of the continent to European exploration and exploitation. Steam-powered riverboats allowed Europeans to navigate rivers like the Nile and the Congo, penetrating deep into regions that were previously inaccessible to them.
And this access facilitated further colonization and resource extraction.
It did. The steam engine in this context became a symbol of European technological superiority and a tool for extending their reach into new territories. This led to the scramble for Africa in the late 19th century, a period of intense competition among European powers.
For control of African territories and their resources.
So the steam engine, while a symbol of progress, also played a role in perpetuating colonial exploitation and reshaping the global map in ways that had lasting consequences.
It did. Its introduction to different parts of the world was often accompanied by violence, displacement, and the exploitation of local populations. However, the story of the steam engine's global impact isn't solely one of colonialism and exploitation.
You're referring to how non-Western powers responded to this technology.
Exactly. Let's look at Japan, for example. The arrival of Commodore Matthew Perry's steam-powered black ships in 1853 was a watershed moment. It exposed the technological gap between Japan and the West and forced the country to end its isolationist policies.
It must have been a shock to the Japanese to see these powerful ships arrive on their shores.
This event triggered a period of rapid modernization, known as the Meiji Restoration. Japan embraced Western technologies, including steam power, to strengthen its economy and military.
And they were successful in this modernization effort.
Remarkably so.
Wow.
Within a few decades, Japan transformed itself from a feudal society to a major industrial and military power.
Interesting.
The steam engine, in this case, served as a catalyst for profound change, propelling Japan onto the world stage.
So Japan's response to the steam engine was one of swift adaptation and modernization.
Yes.
How did other non-Western powers respond?
China's response was in stark contrast to Japan's. The ruling Qing dynasty, facing internal instability and clinging to traditional ways, was much slower to adopt steam technology. They resisted Western influence, viewing it as a threat to their power and cultural identity.
Did this resistance have consequences for China?
Unfortunately, yes. China's reluctance to embrace steam technology and modernize its industries and military left it vulnerable to Western powers. They suffered humiliating defeats in the Opium Wars, which led to the forced opening of Chinese ports to foreign trade and the imposition of unequal treaties that ceded control of key territories to European powers.
So China's failure to adapt to the steam age had profound and long-lasting consequences for its position in the world.
It did. It underscores the importance of a society's ability to adapt to technological change and highlights the geopolitical implications of falling behind in the race for technological advancement.
The steam engine story is full of fascinating contrasts, isn't it?
It is.
It's a story of progress and exploitation, modernization and resistance.
It is. And it's a story that reminds us that technology is never neutral. It's shaped by the social, economic, and political forces of its time, and in turn shapes those forces in profound and often unpredictable ways.
Now, while the steam engine reigned supreme for much of the 19th century, it eventually gave way to a new form of energy, electricity.
That's right. But before we move on to the electrical revolution, there are a few more aspects of the steam engine's legacy to explore. Its environmental impact, for instance, is something we can't overlook.
Let's delve into that. We briefly touched upon the environmental consequences of coal-powered steam engines earlier.
Yes, and it's an aspect that deserves a deeper look. The steam engine, while a marvel of engineering, was also a major contributor to environmental pollution.
Let's pick up our discussion where we left off. You mentioned the steam engine's impact on the environment. Let's dive into that a bit deeper.
The reliance on coal as fuel for steam engines marked the beginning of humanity's large-scale dependence on fossil fuels. This had profound and lasting environmental consequences.
What were some of the immediate environmental impacts?
The most visible impact was air pollution. Factories belched out black smoke and soot, releasing tons of particulate matter into the atmosphere.
That must have had a significant impact on air quality.
It did.
Particularly in industrial cities.
The air in these cities was often thick with smoke and smog, leading to respiratory problems and other health issues. People complained of blackened buildings and laundry. And the air had a distinct acrid smell.
We've seen pictures of cities like London shrouded in a thick layer of smog during this period.
Yes, and it wasn't just an aesthetic problem. This air pollution had real consequences for people's health. Rates of respiratory illnesses, particularly among children and the elderly, were significantly higher in industrial cities.
So the quest for progress through industrialization came at a cost to public health and the environment.
Unfortunately, yes.
And the environmental impact extended beyond air pollution. Coal mining itself had devastating consequences. It led to deforestation as forests were cleared to make way for mines. The landscape was scarred by open pits, waste piles, and mining infrastructure.
And how did coal mining affect water resources?
Mining operations often contaminated water sources with runoff containing heavy metals and other toxins. This polluted water harmed aquatic life and made water unsafe for drinking or irrigation.
It's a stark reminder that technological advancements often have unintended consequences.
Absolutely.
And those consequences can be particularly severe when it comes to the environment.
It underscores the need for careful consideration of the long-term environmental impacts of technology.
Yeah.
The steam engine's legacy in this regard serves as a cautionary tale.
It's interesting to consider how these early experiences with industrial pollution might have shaped our understanding of environmental issues today.
It certainly did.
Yeah.
The negative impacts of coal-powered industrialization led to the first environmental movements.
Okay.
People began to recognize the link between industrial activities and public health problems.
So the steam engine, in a way, planted the seeds for the modern environmental movement.
Yes, though it was a slow and gradual process.
Right.
Early environmentalists focused on issues like urban sanitation, clean water, and reducing air pollution from factories.
Yeah.
These efforts led to reforms in public health policies and regulations.
Right.
And laid the groundwork for a broader understanding of the interconnectedness of human actions in the environment.
The steam engine's story highlights the complex relationship between technological advancement, economic growth, and environmental sustainability.
It does. It's a relationship we're still grappling with today as we face new challenges.
Related to climate change, resource depletion, and pollution.
The steam engine was eventually superseded by a new energy source, electricity.
That's right. But before we move on to the electrical revolution, let's circle back to something you mentioned earlier. You were asking about the transition from steam to electric power. As the 19th century progressed, it became increasingly clear that electricity offered several advantages over steam power.
Like what?
For one, it was more efficient in terms of energy conversion.
How so?
Generating electricity in centralized power plants and then distributing it through wires was more efficient than having individual steam engines in every factory or home.
I see.
This reduced energy losses associated with transmission and allowed for better control and regulation of power.
So electricity offered a more streamlined and scalable way to power industries and homes.
Yes.
What other advantages did it have?
Electricity was also more versatile. It could be used to power a much wider range of devices and applications. From lighting and heating to motors and machinery.
And unlike steam engines, which required bulky boilers, pipes, and a constant supply of fuel. Electric motors were relatively compact and could be easily integrated into different types of machinery.
This made it possible to design and build smaller, more specialized, and more efficient machines, further driving innovation in various sectors.
So while the steam engine's era came to an end,
it did.
Its impact laid the groundwork for the electrical revolution that followed.
Yes. The steam engine's legacy lives on, not just in the infrastructure and industrial growth it spurred, but also in the lessons it taught us about innovation, progress, and the complex interplay of technology, society, and the environment.
It's been a fascinating journey exploring the steam engine and its multifaceted impact on the world.
From its humble beginnings to its role in reshaping global economies and societies. The steam engine's story offers valuable lessons about the power of human ingenuity, the transformative potential of technology, and the importance of responsible innovation.
As we wrap up our deep dive into the world of the steam engine, we hope you've gained a new appreciation.
I hope so.
For this remarkable invention.
And that its story will inspire you to think critically about the impact of technology on our lives and the world around us.
Thank you for joining us on this deep dive.
It was my pleasure.
Until next time.
Okay.
Keep exploring, keep questioning, and keep learning.
Sounds good.
Thanks for listening to Mythos AI. Stay tuned for more concise insights. And remember to hit the like button and subscribe for future episodes.